Alright, so today we're going to learn about box and whisker plots. They represent variability. There's really cool things that you can learn about box and whisker plots. So it represents a data set along a number line by using the lowest value, the greatest value, and the quartiles of the range. A box and whisker plot shows the variability of a data set. So what a box and whisker plot shows is it breaks it up into quarters, and that's where they get the first quartile and the third quartile and the median there to help. It breaks up the data into 25% or fourths. So here's 1/4 of the data. Here's another fourth of the data. Here's 1/4 of the data, and here's another fourth of the data. So a couple things you can tell by the fourths is, between the median and the third quartile, and we're going to talk about what the first quartile and third quartile are later, but this box, this fourth of the box, is smaller than, let's say, this fourth of the box right here. The smaller the fourth means less variability. That means whatever the numbers, let's say this is 5 and 6, that means there's more 5 and 6. There's less variability than this box between like 2 and 5. There's more range of variety of answers in that fourth than the yellow fourth right there. So the more spread out, the bigger the box, the more variability. The closer to the box, less variability. So 5-number summary. What the 5-number summary is the lowest value, first quartile, median, third quartile, and greatest value. And that's your first step into getting the box and whisker plot. So your box and whisker plot, your first step is to order it least to greatest. You can see I already did that. And then your first step is to find the median. So low, high, lowest, highest, lowest, highest, lowest, highest, lowest, highest, and then you have a tie for median between 30s. So when you have a tie, you add them up and find the average. So 30 plus 30 is 60. 60 divided by 2 is 30. So your median is 30. And then you break it up into, here's your lowest half from your median, and then from my median up to my highest number is my upper half of your data set. So from your lower half of your data set to find your first quartile, you're going to find the median of that lower half. So 1, 2. So in between 20 and 26, so add up is 46 divided by 2 is 23. So 23 is what we call your first quartile. I'm just going to say your first Q. And that is your lower median. That's your quartile. I'm going to put M for median for my 30. And then you're going to do the same thing for your upper half. From your median up to your highest point, you're going to find your third quartile, which is your third median. So in between 35 and 33, there's 34. So 34 happens to be your third quartile, or your third median. Again, we use the word quartile because it splits it up into quarters. And then you have your lowest number, which is 14, and you have your highest number of 38. So that's your 5-number summary. You're going to use your 5-number summary to graph. So I started at 14, go to 38, so I'm going to have to count by 2s, and let's see if we can count by 2s and fit it all in. 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Alright, so I start with my box when I'm going to graph it. Your box are your third 3 medians. So I'm going to draw a dot at 23, a dot at 30, and a dot at 34. So those I'm going to form lines, and that's my box. So I'm just going to connect the lines and make a rectangular box. Right, and then my whiskers are, I'm going to put it down my lowest number and then connect that to my box, then down my highest number and connect that to my box. Now, box and whisker shows variability, right? So since if you look at my a low whisker, 14 to 23, that's longer than my high whisker, 30 to 38, or 34 to 38. That means there's more variability between 14 and 23 than there is 34 through 38. And you can even tell by looking at the numbers. 34 through 38, there's a 4 number difference. 14 to 23 is a 9 number difference. It's a more variability in that. So you can see that the lower 25% is more spread out than the highest 25%. So it's really cool if you need a visual on how spread out each quartile is. Alright, so the next step is, again, at any time, pause and go back and try it. But you're going to not make box and whiskers, you're going to interpret box and whisker plots. So the box and whisker plot represents the time in minutes two friends spent doing homework each day. So compare and contrast. So if I just compare these, look at Mia's highest number is 110. Karen's highest number is 75. So you can tell that Mia spent more time on it than Karen. Karen actually spent, if you look at her low number, 0, and Mia spent 30 minutes. So you can compare highest and lowest values as well for time spent doing homework. You can see that Mia's box is longer, so 60 to, let's say, 98. That has more variability, so she's got more variety between the hour and the hour half time frame. So she might spend more hours. She's got more variability right there. And then you can see that Karen's just more consistent. So whether she spends 30 to 45 to 60, that box is very symmetric. So she's more consistent with her middle 50% of your data. Where Mia has more variety there. Yeah. So we gave them a box and whisker plot, a body mass index of a 6th grade class. So what percentage, the fraction of the students have a body mass of at least 22. So 22 is actually your fourth 20%. So this section 22 to 28 is 1/4. So it's either 25% of your students have at least 22 BMI or 1/4 of that fraction, because again it breaks it up into chunks of 4 or 1/4. You can also see that your third quartile is more spread out than your first quartile, which means there's more variability there than 17 through 19, 22 through 28. It's more spread out. Another thing is, if you look, your box, this box considers 50% of your data. So that means 50% of your data is within 3 values, 19 and 22. So you can do, let's just find a range of your box, which is called the interquartile range. So 22 minus 19 is 3. So your IQR, which is your interquartile range, is 3. That means, if you check it out, so this is 25% of your data, and this is 25% of your data. That means 50% of your data is within 3 of 19 through 22. So that's pretty cool. That means you have less variability and a tight data set between 19 and 22 for 50% of your students as well. And then last week we went over skewed left, skewed right, and symmetric. You can do the same thing with your box and whisker plot. So if your whisker is longer on your left, that means there's more variability on your left, so it's skewed left. If it's symmetric, you know, it's like a mirror. Median is in the middle. Your data points and your whiskers look pretty much the same from your left to your right. If you're skewed right, that means you have more variability on the right. That means your whisker is longer on the right. So if you look at the double box and whisker plot that's shown here, it's color coded for you. So the crocodile is blue, the alligator is red. So it represents the lifespans of crocodiles and alligators at a zoo. identify the shape of each distribution. So to me, the one thing that pops out is the alligator. Alligator looks symmetric, so I'm just going to write symmetric for the alligator on here, because what do I have to lose? So that's symmetric. And then if you look for the crocodile looks like it has a longer leaf to your left. So what I would say is it is skewed left. There we go. Again, that's because look at there's more variability on the left side of the box, so I would say it's skewed left. Now how I know it's more variability, because if this was the median right here, it's got a long way to go to your first quartile, so it's more spread out. Where the box in for the alligator is more symmetric, it's pretty much mirrored. And then which reptiles' lifespans are more spread out? I would say the crocodile's more spread out. You can see it in the box, and you also see the range is 45 to 80, which is more than 40 to 60. So yeah, so that's a box and whisker plot. I would suggest going back and just going back through all of these: symmetric, skewed left, and skewed right. Pausing and reading, and maybe trying to redo it and see what you come up with.